Hello, this is question 7 from the 2015 MAT. In this question, we will study a mechanism for producing a set of words. We will only consider words containing the letters A and or B that have at least a length of at least 1. We will make use of variables, which we shall write as capital letters, including a special start variable called S. We will also use rules, which show how a variable can be replaced by a sequence of variables and or letters. Okay. So variables can lead to other variables, right? Starting with the start variable S, we repeatedly replace one of the variables according to one of the rules in any order until no variables remain. So for example, suppose these are the rules. So we've got start variable, 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 and that variable can do different things here for A then. So S can go to AB, A can go to either duplicating itself or to the letter A, and B goes to BB. We can produce the word AABB as follows. At each point, the variable that is replaced is underlined. So S is replaced by AB. We then replace AB by, replace A by AA. So we've got AAB. Then we replace A by little a to get AB. And then, okay, right, I can see what they're doing. It's a bit fiddly with these two A's, but okay. Show that the above rules can be used to produce all words in the form A to the N BB with N greater than or equal to 1, where AN represents N consecutive A's. Also, briefly explain why the rules can be used to produce no other words. Right. Show the above rules can be used to produce all words in the form ANBB. Right, so let's step through these. There's so many permutations on this. Right, so we have to start with S. So they've told us we have to start with S, which goes to A, B. Right, so we've got, okay, A's got the ambiguity in it, so let's deal with B. So B must go to BB. Is the only option that we've got. So that leaves, so leaving, what we got? A and then two lowercase b's. Right. A can go to A or AA. Okay, right, and then we're just building up A's. So, and each A we add, each capital A, we add to the sequence of, what do they call them, variables, of variables, can add an extra, add another lowercase a. Lowercase a. Right, so therefore we construct AN, yeah, AN has to be at least 1. I was just checking that there. A to the N, B, B. And nothing else. We can't, and no other words. Because A's only produce A's. A's produce A's and B produces B's. A's produce A's and B produces B's. Okay, a little long-winded for the first part of the question. Part 2, give a precise description of the words produced by the following rules. So we've got S goes to AB or it goes to ASB. So we either go to, so we're going AB or ASB, which means, which then would go to, so then AABB, or, so wait a minute, S could go to ASB. So what would happen if we replace that? S goes to ASB. So in between that, we have to then put, okay, AASBB. is what we'll be doing. We'll be taking the ASB and putting an A at the start, at the finish. So we're just building up AABBs. So, etc. So we'll be getting A to the N, B to the N, because we're always going to get the same number of each one. And that's going to be for N greater than or equal to 1. Right, well, that was easier than the first bit of the question, I think. Third part, a palindrome is a word that reads the same forwards and backwards. For example, BB, AA, BB. Give rules that produce all palindromes and no other words. All palindromes and no other words. Right, so for S then, I mean, you can see we can have different start functions. We don't have to just have one S. They've put multiple ones there. So for S, we could go, we have to have things that are the same at the start or the end. So we could have AA, we could have BB, and then we're going to have other ones where we're putting things in the middle. And what we put in the middle is going to have to be, well, also a palindrome. If we just stuck S in the middle, so we could say, well, we've got S goes to A, S, A, or we could have S goes to B, S, B. What's the point of having these other letters now I think of it? I mean, now they've put two S's here in the same rules. Why did we have to have all of these be different? I don't really see. Why couldn't these be, why can't they all just be called S? Why can't every variable be called S? Would anything change if we did that? If we had S goes to SS and then S goes to, well, maybe it'd have a difference there. I don't know. S goes to A. Yeah, that would change things because here you have to actually split out the fact that we don't want mixing of these. So it does make a difference, I suppose. Yeah, because otherwise we could just get a whole string of A's. Whereas here we're not so bothered, are we? Because we could have, if we had this combination, we're going to get AA, BB, AAAA, ABBA, BBBB, BAAB. So they're all fine, except they're all even length. So we need to have odd length options for these as well, don't we? So we need to have an S goes to an A or an S goes to a B, because we could start with any of those as well. I suppose that's another thing with these, is you can't start with the ones that don't begin with an S. Whereas here we could start with an A or a B, and then we can do 2 A's, 3 A's, 2 B's, 3 B's, 4 B's, 5 B's. Yeah, so we can we do 5 B's? How would we do 5 B's? We'd have to do B. How would we do 5 B's? We'd have to put an S inside it again, wouldn't we? So we'd have to do BSB, and then we'd have to take that and put that inside B's again, and then replace. Yes, we do that one twice, and then put a B in the middle. So that would be 5 B's, right? So that's how we can get the odd length palindromes. So that's going to be all the options. That's going to work out fine then. If we got those 6, then we're okay, because we can interchange A's and B's any way we want by using the middle two, and then we can just keep stacking them. So yeah, that's no problem at all. Right, okay, so that's that. I need a new sheet then. So now part 4, consider the words with the same number of A's and B's. Right, so write down rules that produce these words and no others. So we've always got to add them in pairs. So we could have an AB from the start. We could have a BA from the start. So they're our start options. And then with these, we just need to be able to add A's and B's whatever way round we want. So we could go A, S, B, or we could go S, B, S, A. Is that going to do everything? Is there anything we're not going to be able to create off of that for the same number of A's and B's? Right, to produce those words and no other words. So, oh, again, they're all even length. Oh, but they have to be even length because they've got the same number of A's and B's. I'm trying to think if there's going to be anything that I can't make out of these. So say we wanted to do, well, that would do A, B, A, B. It would do A, A, B, B. It does that, it does that. What about if we were going to 6 length? So we could do A, B. We're going to run into problems here. So say we wanted to do A, B, A, B, A, B. We're not going to be able to do that, are we? Because we'd do A, B, put that inside, gives us A, B, B. Oh no, but if we put BA inside, so we could go A, B, A, B. But then how do we get another A at the start or the end? No, I don't really see how we can do A, B, A, B, A, B off of this. I'm missing something. Because we'd have to end with that one, which means inside. Oh, actually, we probably would. Let's see. So we've got to end with that one, which means inside we would have BA, BA, which we can do. We can take that and put it into there, which would give us BA, BA. So yeah, we can do that. We can do, I think we can do anything here, can't we? So say we wanted to do A, B, A, B, B, something like that. Ah, no, what if we want an A at the start and a B at the end? An A at the end as well. That's not going to work, is it? No. So yeah, let's see if we want A, B, 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 A. So that means we have to end. Yeah, we can't do that. We can't do that at all because we'd have to end on one of these two, which means we get a B at the start and the A at the end. So how would we get A? We can set up, this 4 sets up any combination that has a different start and end letter. So how do we then get the same start and end letter? Then, well, we could add them together, I suppose, couldn't we? Because we can do AA, BB, and we can do BA. So if you've got different letters at either end, we don't have to work. So how would we do A, B, B, A? Even if we want to do A, B, B, A, we can't do that off of this starting setup either. But we can do A, B, and we can do BA. So we just need to add the two together. And the same with BAAB. So we also need an S goes to SS, I think, in order to get the start and end letters being the same. And then I think we got all of our permutations. Yeah, I'm a little unconvinced that that's maybe covered everything. It seems to have covered everything because we can definitely get everything that starts with and ends with different letters. And then, yeah, that would, I'm 99% convinced on that one. And I don't really know what else to do to check it. So I'm going to leave that as, and we're always adding them in pairs. That's the main thing. We can guarantee that there's no other words. We've always got the same number of A's and B's. That's a certainty on that. And I'm pretty certain on the other bit as well. So part 5, suppose you are given a collection of rules that produces the words in L1. L1? What was L1? Okay, words in L1. They haven't mentioned L anywhere, have they? And another collection of rules that produces the words in L2. What is this, a list of words? Have I missed the letter L turn up somewhere? No, okay, I'm just going to go with that's what it is then. So we got one set of words and we got another set of words. Show how to produce a single set of rules that produce all words in L1 or L2 or both. Or a single set of rules produce all the words in L1 or L2 or both. What does that mean? One or the other or both. That produce all words in those. Right, okay, right. So they're separate, but you could do the whole lot and no other words. You may introduce new rules if you want. Just still slightly thrown by this wording. So how have they put this before then? So in the last part, consider the words with the same number of A's and B's. Right, write down the rules that produce these words and no others. So write down the rules that produce these words and no others. So every time you go in, you get a word. This is what we're doing when we go into one of these sequences. We've set up these rules. We go into the mechanism and we get a word out. So you have to run it multiple times in order to get all of the words. So say in here, how to produce a single set of rules that produce all words in L1 or L2 or both. Well, that's, I don't know why they've said it a different way. It just doesn't really make any sense. Every time we go in, we get a word. So if it's producing potentially all of them, then we could just get the L1 ones, or we could get the L2. So I don't see why they've changed the wording. It doesn't make any sense to me because it's still the same as the previous parts of the question. Anyway, right, so we got two previous mechanisms then. So we've got mechanism 1, which has got some start point, and then it's got a whole load of variables. It's got some set of variables, and that will end up giving us a list of words number 1. Then we got mechanism 2, which has got some start point, which goes to a whole load of variables, and that then goes off to give us list 2. And we now want a new start point, which can then produce all of these words. So, well, if we rename that T and we rename that U, then we can just say S goes to T, S goes to U, and then make sure we don't have duplicate variable names in these. And combine the two sets of variables and make sure they don't have and give them unique names. Give them unique names. But I still don't get the point of what they've written here. That will produce all the words in L1 or L2 or both. Well, yeah, I mean, it is. How's that any different to saying it will give all of the words in L1 and L2? Because even if you say it gives all of the words in L1 and L2, it doesn't mean to say you have to run it for every single word. You could still run it and, the number of times there are words in L1, and every single time go down what we're now calling T, and you get the L1 list. So I'm not really following their language here on the last part of the question. I'm assuming this is what they want, because you can't run it multiple times. We're not putting a loop on the start thing. You get is one execution, one word. So that seems very odd to me, unless I'm missing something as to why they've written it that way. And I'm still, I mean, these L1s and L2s they've dropped in. I mean, I'm scanning through the question again. I can't see any mention of those. So I'm assuming that is just what I'm deciding it is. It is just a list of words. So yeah, it's a bit of a weird finish to a fairly tedious question anyway. I would say it was quite tough. The first part was difficult. The second part was easy enough. Third and fourth parts weren't simple at all. And the last part is just confusing in the way they've written it. If I've interpreted their strange way of writing it correctly, then I think this is the answer. But yeah, not entirely happy with this question. And as I say, I could be reading it the wrong way. So if you can see something that I've missed, then leave it in the comments. But otherwise, I think they've made this more opaque than it needs to be. This seems to be an exercise in trying to understand what it is they actually want, rather than actually doing any of the problem solving involved in the question. So I'm not a fan of this one at all. But there you go. Maybe you've got a better idea. Let me know if you do.